Hey guys, it's Harrison. Today we are going to be learning about absolute value equations and absolute value inequalities. First, we will review what absolute value is. Absolute value can be described as a number's distance from zero on a number line. Let's look at an example of this. Absolute value is written with these two lines here. So, in this case, we are looking for the absolute value of 6. As shown above, 6 is 6 digits away from 0. Therefore, the absolute value of 6 is 6. Okay, now let's look at a similar example. We are finding the absolute value of negative 6 here. So, just as we did above, we will find how many digits negative 6 is away from 0. This is also 6, so this means that the absolute value of 6 is equal to the absolute value of negative 6. Now, let's get into absolute value equations. There are 3 rules in solving absolute value equations. These are 1. Isolate the absolute value. 2. Split the equation into 2 separate equations. And 3. Solve both equations. This may not make sense now, but let's look at an example. This equation is asking us to solve the absolute value of 5 minus 2x minus 11 equals 0. The first step is to isolate the absolute value. We will do this by adding 11 to both sides, and this gets us the absolute value of 5 minus 2x equals 11. The next step is to split the equation into 2 separate equations. When doing this, we will keep the equation the same on this side, and on the other, we will make the right side negative. So the equation will be 5 minus 2x equals 11, and the other will be 5 minus 2x equals negative 11. We then solve both equations by subtracting 5 from both sides, and then dividing by negative 2. This leads to the solution x equals negative 3 or x equals 8. This can also be written like this, and some algebra teachers may prefer you to write it like this. Alright, let's look at another example. This problem is asking us to solve 4 times the absolute value of 2x minus 1 minus 2 equals 34. First, we're going to isolate the absolute value from the rest of the equation. We'll do this by first adding 2 to both sides, and then dividing 4 on both sides. This leads us to the absolute value of 2x minus 1 equals 9. Now that the absolute value is isolated, we will split the equation into 2. Like the other example, we'll keep it the same on this side, and we'll make the right side negative. Now we solve both equations by adding 1 to both sides, and then dividing by 2 on both sides. This leads us to the solution x equals negative 4, or x equals 5. The or is very important when you write the equation. Okay, here's the last example of absolute value equations. 6 times the absolute value of 2x plus 3 minus 7 equals 2 times the absolute value of 2x plus 3 plus 1. This one is a little more difficult because we have absolute values on both sides, but we'll get into that later. Our first step is to, again, isolate the absolute value. We'll first add 7 to both sides, and we'll get 6 times the absolute value of 2x plus 3 is equal to 2 times the absolute value of 2x plus 3 plus 8. Notice that 6 times the absolute value of 2x plus 3 and 2 times the absolute value of 2x plus 3 are like terms. Therefore, we can use the distributive property to simplify. We will subtract 2 times the absolute value of 2x plus 3 on both sides, and we will then get 4 times the absolute value of 2x plus 3 equals 8. We can then divide 4 on both sides to finally isolate the absolute value. Now we have to split the equation into two separate equations. Like the other examples, we will keep the equation the same on this side, and we will make the right side negative on the other. To simplify, or to solve the equation, we will subtract 3 from both sides, and then we will divide by 2. This gets us x equals negative 5 over 2, or x equals negative 1/2. Now we will get into absolute value inequalities. There are two different types of inequalities that we will solve and graph. These are the less than inequalities, which use the word and in the solution, and the greater than inequalities, which use the word or in the solution. Solving absolute value inequalities is similar to solving absolute value equations, but when we split the two absolute value equations, or when we split it into two, and we make the right side negative, we must also flip the sign. So as you can see, when we split it into 4 and negative 4, we have to flip the sign on the negative. When graphing these inequalities, the less than inequalities will be a line in between the 2 points here, and the greater inequalities will be 2 continuous lines from the 2 points, and they'll be facing away from each other. Okay, let's look at an example. This problem is asking us to solve the absolute value of x minus 4 is less than 3. We'll first write the original problem, and then we'll separate it into two different equations. The first will be the same, and the second we will make the right side negative and flip the sign. Then we add 4 to both sides, and then we get our solution: x is greater than 1 and x is less than 7. We graph this by putting the 2 points down and drawing a line in between it because it is an and. Our next inequality is a greater than inequality, so we know that it will be or, and it will look something like this, but we'll save that for later. We will first write the original inequality, and then we will separate it into two by keeping it the same here and making the right side negative while also flipping the sign. Then we can subtract 2 from both sides to get x is less than or equal to negative 7, or x is greater than or equal to 3. We graph this by graphing x is less than or equal to negative 7, like so, and x is greater than or equal to 3, like this. And because it is an or, it has the 2 continuous lines facing away from each other on the 2 points. The last thing we are going to look at is inequalities with no solution and inequalities with all real numbers as the solution. There is no solution when the inequality is less than a negative. This is because absolute values are always positive, and this would make the inequalities false. The solution is all real numbers when the inequality is greater than a negative number. This is again because all absolute values are positive. Let's look at some examples. So all of these inequalities have no solution because it's trying to tell us that the absolute values, which are always going to be positive numbers, are less than a negative number. And a positive number cannot be less than a negative number, so therefore there will be no solution. These inequalities have the solution all real numbers because it is saying that a positive number is greater than a negative number. this will always be true no matter what absolute value you put. So whenever you see an absolute value less than a negative, it'll automatically be no solution. And when you see an absolute value greater than a negative, it'll automatically be all real numbers. That's it for today. Thank you guys for watching.